today our topic of discussion is central tendency of data. Then we will discuss on outlier and box plots. Now try to understand in which cases we have to consider this special kind of features while data analysis. Say in certain cases you are comparing two groups and you have calculated the central tendency of data. Now here the question is, what do you mean by central tendency of data? Central tendency of data means it is a mean of the data, median or mode for both the groups. So whenever you are considering two groups and whenever you are measuring central tendency of both the groups, basically you are focusing on the measurement of mean, median and mode, right? So now I will discuss what is the basic consideration of these three, but try to understand sometimes it may happen that this mean, median and mode are same for both the groups. Say you have one set of data over here and you have another set of data over here, and you are measuring central tendency of the data for this group and central tendency of the data for this group. And unfortunately, you came up with a solution where mean, median modes are same for both the groups. So this indicates that if you adequately describe a distribution for the data, sometimes it may need more information than the measurement of the central tendency. Means whatever measurement you have got, they are not enough. So whenever you want to visualize a data in a proper way, in order to extract some information from that data, so central tendency is not enough, right? So in that case, you have to measure some specific concept. That is, either you have to measure the range of the data, or you have to measure the interquartile range, which is also known as IQR of the data, or you can use box plot. And box plot is a good indication where this graphical display will show how the values in a distribution are spread out. So basically, whenever the central tendency of the data is not enough to give you the data insight, then you can opt for these three cases. Now, what is this range? See, if you try out this concept, finding range, so it is basically the difference between the highest value and the lowest value. So whenever you are considering the range, it will only consider the count of extreme values. And sometimes it may not give you a good impact on data variability. So this is the important point you have to keep in mind. So the first question that I am going to ask you in the exam, that is, whenever central tendency of the data is not enough, then we can opt for calculating the data range. So what are the drawback of calculating the range of data? So you have to answer it in this manner, that is, range concept takes the highest and the lowest value and its difference. And what will appear over here, range will consider the count of extreme values, and as a result we will not get enough information about the data variability. So in that case, the only option is you have to opt for IQR. So here the first consideration is why we need to calculate interquartile range. The answer is that whenever central tendency of the data is not giving you the proper data insight, then you can try out range, and range is not an option because it will not give you any information about the data variability. Then we will go for IQR. Now here we have to focus on IQR. We have to understand it in more details. So now let's consider the concept of IQR. So basically, if I consider IQR in case of data visualization, what it provides? So it basically gives another measure of variability. Since the concept of variability is not precise in case of using range, then IQR is an option, or you can say that it is probably the best option than range, that can give you the measure of variability. So it is better measure of a dispersion than the range. So what is this concept? I will explain you. So these two terms are very important. What is data dispersion and what is the variability of the data? So dispersion means basically it leaves out the extreme values. So in case of range, what it is doing, it is just taking the difference between two values, highest minus lowest. So it is basically considering the ranges. It is considering the extreme values. However, IQR is better than range because it leaves out the extreme values. So this point you have to keep in mind. So how this IQR will work, now I am showing you a diagram so that you could understand that what is the meaning of IQR. So if you ask me this question that what IQR does, I will tell you that it just equally divides the distribution into four equal parts, which are also known as quartiles. Now consider one diagram like this. Say here we are talking about the normal distribution like this. Normal distribution means what? Whenever we have the median, we are expecting that in both the sides we have same amount of data points. So then it will be a bell curved shape and it is a normal distribution. See, if this is the median, now you can say that this is the smallest value. If this graph ends over here, so this is the smallest value, and here we will get the highest value. So this is the smallest value, or you can say it is the minimum value, and this is the largest value, or you can say that it is the maximum value. And now IQR does what? It equally divides the data distribution into four parts. Means like this. So you can say that this is the 25% of the data. This is another 25% of the data. Similarly, these are the 25% of the data. So we will get the equal four parts. So this part is known as 25th percentile. This one is known as 75th percentile. And median means it is known as 50th percentile. So these are the names. So basically in case of dealing with IQR, whenever we are dividing the data distribution into four part equal divisions, then this 25th percentile is also known as Q1. And this 75th percentile are also known as Q3. It is known as first quartile and this is known as third quartile. Right? And what is IQR? Now you will understand. This interquartile range means Q3 minus Q1. So this is the formula of IQR. So interquartile range is the difference, or you can say that it is the distance between the third quartile and the first quartile. So now you can ask me one question that how to calculate this IQR. Now I'm just giving you some points. So if you want to calculate the IQR, you have to first do one thing. Whenever the data set is given to you or set of numbers are given to you, then first you have to order the data from low to high. This is the first thing you have to consider. Now, what is the second point? Then you have to find the median, that is Q2. Now, how to find the median? I will show you two mechanisms. Now, the third step will be then we have to find Q1. So, how we can find Q1? If this is Q2, means if this is the median value, if we look at the left side, then only we can find the Q1 because we have to use Q1 while calculating IQR. Then obviously What is the fourth step? Similarly, we have to find Q3. How we can find Q3? We know the median, and if we look at the right side of the median, then we will find Q3. So once Q1 and Q3 we have found, then the difference will be the IQR. So this is how we are going to calculate the IQR. But the thing is, whenever a particular problem is given to you, finding IQR is not so easy because it will create some more problems. And try to understand, here we are not doing any mathematical class. What is our aim? Our aim is to understand the insight of the data. Means whenever I am calculating IQR, what is the tendency, means what we are going to find, what we are going to infer. This is the main question that we have to learn as a part of data visualization. So basically why we are finding this IQR, so that we could find out the concept of outlier. Now, what is this outlier and how it is affecting our data set? Today we will discuss it mathematically as well as by coding. So let's start with a simple problem and try to understand how to solve that problem and what insight we can derive from that problem. So now here, say a problem is given to you that we have to find the minimum, means the minimum value, the median. Now we know median is also known as Q2. The lower quartile means we know that it is known as Q1, the left portion of the Q2. Then we have to find out upper quartile. It is also known as Q3. We know that, we have just discussed it right now. And we have also find maximum for the data. Now what are the data set given to us? Say we have given some data like this: 48, 56, 63, 50, 46, 25, 52, 49, 53, 42, 55, 51, then 58, 40, and say 69. Now we have a pretty good set of data. So now what we have to do? Say we have a lots of tasks we have to apply on this data set, but whenever we are talking about calculating IQR, the first thing is we have to arrange the data, starting from the lowest data to the highest one. So if you arrange this data set, the minimum data is this one. So start from 25. So I'm just arranging the data. Then we will have 40, then 42, then 46, then 48, then 49, 50, 51, 52, 53, 55, 56, 58, 63, and 69. So the first step is done. So whatever data set is given to us, first we have to arrange it. Now see what was our second step. So our second step is we have to find out the median. Now here, how many data is there? Let's count it. So we have total 15 data, right? So now see how to find out median. Then probably there will be two questions. If we have even set of data and if we have odd set of data, how to calculate the median? This is the important thing. So whenever you have total number of 15 data, if you divide this data by 2, then what you will get? That is 7.5, right? So in that case, if you consider the ceiling value of 7.5, it will be near about 8, right? So whenever you have odd number of data, then divide the data by 2 and take the ceiling value, and then whatever number you are getting, that number will be the median of data, means 8. So let's check 1, 2, 3, 4, 5, 6, 7, 8. So this is the median of the total data set. So this is the first thing. Now, how to find out the Q1 and Q3? Median means we have already got the Q2. Now we have to find out Q1. Q1 means the left side of the Q2. Now count how many data points are there. So now you have how many data? 7 data. So which one will be the median if I apply the same logic over here? So 46 is the median for this data points. So it will be our Q1. Now how many data set we are having over here? Again 7. So the fourth data will be the Q3, that is 56. So it will be Q3. So now we know that what is the formula of finding IQR? That is Q3 minus Q1. So what is Q1 and Q3? So we can get 56 minus 46. That is IQR is 10. Right? Now, this is the important part that we haven't discussed. See, whenever we are calculating IQR, then how we are calculating the insight of the data. So after calculating IQR, there will be two important points. First, we have to find out the lowest of the acceptable range, and then we have to find out the highest of the acceptable range. Because now try to understand why we are talking about range. So after calculating IQR, actually we are going to find out the outlier. Now from here, we can get a minimal idea about the outlier. What is this outlier? The value which comes beyond this lowest and highest range. Means value that comes out of this range can be considered as outliers. Right? So, finding acceptable range after calculating IQR is the first notion. So, in this case, how to find out the lowest of the acceptable range? So, whatever value you have got as the median here, that is 46, that I am talking about Q1. So, the formula is Q1 minus 1.5. It comes in the formula. It is there, it's a constant value into IQR. This is the formula of finding lowest acceptable range. And how to find out the highest acceptable range? It is the formula Q3 plus 1.5 into IQR, right? So from here, if you calculate, then the lowest acceptable range will be 46 minus 1.5 into 10. It will be 31. And in this case, the highest acceptable range will be 56 plus 1.5 into 10, that is 71. So we have got this range. But try to understand what was our question. Our question was we have to find out the minimum and maximum value. So in that case, what happens? People usually answer it as, okay, minimum is 25 and maximum is 69. No, try to understand. So after finding lowest and highest range, what we can observe? See, this is the minimum value. Now see, this 25 is less than this 31. Means minimum value of the data set is less than the lowest of the acceptable range. So basically it is identified as outlier, right? So how to find out outlier? This is the first concept. Whatever minimum value you have got and whatever lowest acceptable range you have got, if this lowest value is less than this range, then this is the outlier. Now consider this thing. There is no outlier in the higher side. How I can state that? See the highest value and see the acceptable range. So in that case, there is no outlier. So now which value is the minimum among the data set? Since we have identified 25 as outlier, so we have to reject this data. And whatever comes immediately after this data, see, it is in the acceptable range. So we can say that the minimum value of the data set is 40. So we have got the first answer. We have also got the answer Q1. Q1 is 46. This is the answer. What is the value of Q2? It is 51. And what is the value of Q3? It is 56. Now here the question is, what is the maximum value? See, maximum value will be 69 because it is in the range. So the maximum value will be definitely 69. Now the question is, what is the mean value? Mean value means we have to find out the mean value of this data range. It is also important. So if you ask me the definition of the mean, we know that the mean is the average of the data set. So in this case, how to calculate the average of the data set? See, the only trick is that you have to understand the mean value will be calculated excluding this outlier value. Then you add up all the values and divide it by the total number of values, right? So in that case, just make a note. If outlier is identified while taking the average, you have to exclude the outlier and then you could calculate the mean. So I have already done this one. The mean value will be near about 52.285. So at the beginning of the class, what we have discussed, calculating central tendency of the data is not enough. Central tendency means mean, median, mode. Because first you have to find out the IQR, then only you can find out the range, and then only you can find out the outliers of the data, right? And then only you can find what is the actual mean, what is actual max, and what is actual mean of the data. So that's why central tendency calculation at the beginning of the data will not work out in case of data visualization and analysis. Now here the question is, what is this outlier, means how we can deal with this outliers. This is the important question we have to think. So here I have just already prepared one code. So let's try out this code. See, today we have to work on, or we have to understand the box plot also. See, we already know that what is this kind of plot is all about. And whenever we are plotting this box plot, what is the meaning of the box plot, we have to understand. So we have already discussed about IQR, right? Now, how this IQR is important in understanding this kind of box plot, we have to understand first. So whenever we see any kind of box plot like this, so what is the meaning of this box plot? See, here this is known as median. So we have already talked about median, right? How to calculate median. So this line is median. And this part is basically Q1, the lower quartile. So we know mathematically how to calculate lower quartile, that is Q1. And this is the upper quartile, that is Q3. And median means this is the Q2. And if you find this kind of values somewhere in the box plot, so these are known as outliers. So we have to reject those values that can be considered as outliers. So basically, this part is known as upper whisker and this part is known as lower whisker, right? So that's why box plot sometimes is also known as whisker plot. So this is the basic interpretation. So what we have learned so far as a part of IQR, this is how the box plot will be interpreted. So if you ask me this question, that is, what is the definition of outlier? So we can say that outliers are the data points that differs from other observations, right? Or those which lies at a distance from other data. So this is the concept of outlier. Now we will try to create some outlier and try to solve this problem using Python. Now you can ask me one question. This is just a test program. That is, we can create outliers. See, here what I am doing, I am just importing three libraries. And then I'm creating random number. So how to create a random number in Python? You have to use this randet. So basically, this is how we can create random numbers. So rand int is the function that will generate random numbers between 1 to 20. And then I am just imputing two outliers. So since 1 to 20 is my range, and here I'm just imputing two numbers 28 and 30, which is considered as outlier. So how to impute this? We have to use append function for that. So I am appending this two value into array ARR. Array ARR is containing this random values between 1 to 20. And a new array is created ARR1, which is containing the outliers as well as the randomly generated 20 values. And see, this is the output. So now we know that this is the set of data points where we have outliers, right? So now how to see the outliers? Here we can use box plot. So how to use this box plot? You have one matplotlib library where we will use pyplot. This plt is the alias of this library, and if I write plt.boxplot function and I'm just plotting this array ARR1 where we have the data points and as well as outliers, then we will see the box plot will look like this. See, we have two outliers, that is 28 and 30, and see, it is already visible. So I think now you have understood how to identify an outlier in the box plot. Now, how to calculate IQR? So at the beginning of the class, I have already discussed about the steps of calculating IQR and how to find out the lower range and the upper range. So in that case, I'm just implementing this concept. So ARR is containing the data values with outliers, and here I'm just calculating Q1, right? And for calculating Q1, you have to use this quartile function. And then I'm calculating Q3, right? And then I'm just calculating IQR Q3 minus Q1. So I have already discussed everything. And how to calculate upper bound and lower bound, this formula I have already explained. So by using this simple code, means whatever formula I have written so far in solving the mathematical problem, the same formula I have used here in order to find out the upper bound and the lower bound. And see, it is showing which one is the upper bound, which one is the lower bound, and which one is the IQR of my data. Now here try to understand. I will discuss one very important point. Have you ever heard about domain knowledge? See, we have probably already read about domain knowledge. So why it is important? See, domain knowledge is essential for a data scientist. And why it is important today I will explain. See, domain knowledge can help you in identifying outliers. So if you want to find out outlier in some data set, you have to know about the domain of the data set. Means I'm just giving you a simple example. Say you have knowledge of a real estate market, say in certain location. Then you can identify which prices are usually high and which one is usually low. Likewise, say a doctor knows that normal resting heart rate for adult ranges from say 60 to 100 beats per minute. So this is a kind of domain knowledge. Means if you have the domain knowledge, then you can easily identify the outlier in the data set. Try to understand. Say here I have one data set, real estate data, consider. So this is the price of some properties listed. And in that case, if you have the real estate domain knowledge, then you can apply the concept of filter for identifying the outliers. So what do you mean by filter? Filter means if you have the domain knowledge, you know that which prices are extraordinarily high and which prices are extraordinarily low. So these are the outliers. So in that case, if you apply filter like this, if you write this kind of query, say this market price is less than this one, this market price is greater than this one. So this is the kind of range you are setting, and how to apply these values, it is completely dependent on the data set. Means domain wise this value will be altered. So here my point is, whenever you have some unknown data set, just like real estate or some medical data set, you can first deal with that data set and you can see the data set values. Means if you have the data set of heartbeat, and I have already explained, if you are a doctor, then you have the knowledge about what should be the normal heart range for a adult person per minute, then you can easily apply the filter on it, say less than 60 or greater than 100. And then if you apply this kind of concept, then you can identify the outlier. So here what I am discussing. See, how to identify an outlier. First you calculate IQR, then find out upper bound and lower bound, and then only you can calculate. This is one option. Second option is, if you know the details of the data, domain knowledge of the data. Say I have two sets of data, one is real estate data and one is a heartbeat data. So in that case, in this set of data, how to identify outliers? You can apply filter. Filter means just you can set the range. How to set the range? So this is the set of range for real estate and this is the set of range for heartbeat. Say, and then easily this outlier will be detected. So you can try out this code. And also, I have used one very popular data set, and it is known as California housing data set. If you can use this line, then automatically this California housing data set will be loaded. And from where this data set will be loaded, the repository of this data is this one, sklearn.dataset. From this location, this data set will be automatically loaded. So you just write this line and use another additional library pandas, and you will get the California dataset. And this dataset will look like this. So it has some features in the dataset and it has some properties. And from this dataset, you can find out the outliers, something like this. Means if you apply box plot. So how to create a box plot? So we have to write the data frame name, then plot, and then you will get the box plot over here. You can try out this code. See, you will find many outliers in this data set. And I have made some footnote over here. What conclusion we are getting from this code, everything is given to you. But here, what is our topic of discussion? Focus on this. So I'm talking about outliers. Now see, sometimes we have got this kind of data set. Data set means we have just one list of data set, that is a one variable price. And if you see this California housing price data set, see we have so many features. So many features means so many variables. All these are variables. Column names are variables. So from this observation, we can identify another beautiful observation, that is how many types of outliers are there. So if I ask you this question, we can say that there are two types of outlier. One is univariate outlier and another one is multivariate outlier. So what do you mean by univariate outlier? So a univariate outlier is a data point that consists of an extreme value on one variable. So whenever we are identifying outlier in this scenario where we have only one variable, say price, and here we have identified some outlier, then it is a univariate outlier. And what do you mean by multivariate outlier? See, multivariate outlier comes here. So in this data set, we have so many variables. So here my point is, multivariate outlier means it is a combination of unusual values on two variables or more variables. Multivariate means minimum two variables should be there where we have identified outliers or more. So in this case, we can say that in the California housing price data set, since we have so many variables and from the box plot, we have identified so many outliers, and this outliers comes under multivariate outliers. Whereas in heart rate or this real estate price, we have univariate outliers.